I've prepared the timeline somewhat in order to demonstrate some further functions. And what I've done is I've recorded 2 further voiceover recordings. However, all 3 of the recordings have varying levels. I did this in the voiceover dialog by adjusting the volume slider. So, the loudest one I moved it to the right, and the more quiet recording I moved the slider to the left. If we look in our timeline though, we can see that the waveforms look fairly similar. I'll make the track somewhat larger. Yeah, and I can see that there is a slight difference in size, but not an extreme difference. If, however, I go back into the user settings and adjust the waveform display to the linear setting, then we can see the difference is more dramatic. And the reason for this is that the waveforms are shown in the linear method, showing their exact volume. And so we can see that my first recording is probably with an average volume. The second is very loud, and the third is very quiet. I'll play it all.
This is an example for a voice-over recording. One more voice-over recording. And now a very quiet one.
So yes, we can hear there is a clear difference in volume between the 3 recordings. I've done this on purpose, obviously. However, this could happen in reality. This could happen, for example, if you record on different days, or, for example, with a different microphone or a different distance to the microphone. Then you might end up with such results. As this could be a fairly common problem, Edius has some functions to help solve this problem, and I'll show them now. The main function to deal with this problem is called the normalize function, and I'll use this on the first recording. I'll select it, and then, under Clip, I can call up the normalize function. A window appears where I can specify the audio level, and anyone who knows a bit about audio recording will know that -20 dB is actually remarkably quiet. I'll use it anyway, and confirm with OK. Now my recording appears to be a little bit quieter than before. I'll listen to it.
This is an example for a voice-over recording.
So we can hear that there hasn't been a major change, but I'll undo and go back into the function. Clip, normalize. And anyone who knows the normalize function from other programs might wonder why the normalize function works how it does. Because in other programs, normalize usually functions by taking the loudest peak in a recording and bringing that up to the specified level. This certainly wasn't the case here. The clip was clearly much louder than the peak being at -20 dB. What happens with Edius, which is somewhat different to other programs, is that Edius uses the normalize function to adjust the average level of this clip to the specified level. So what this would mean is that if I was to specify 0 dB, then Edius would try and adjust my recording so that the average level was 0 dB, and that would certainly ruin any recording. On the other hand, having it function this way means that a small peak in the level won't mean that my entire clip is brought down to a very low level. It actually brings the clip up to a good average level. So, I could maybe try with an average maximum level of -15 dB. I'll try that, and then we can see that the clip is somewhat louder.
This is an example for a voice-over recording.
I could do this with the other clips. I'll do it with the final clip. Normalize -15 dB. And now it should be the same volume as the first one.
And now a very quiet one.
Yes, and it was spoken in a slightly different way, but basically we can say that the level is very similar to that of my first clip. I'll undo both of these normalize functions and show a nice option with Edius. And this is that I can select multiple clips with the lasso, or with the usual methods of selecting multiple clips. And now, when I do the normalize function, all 3 clips will be brought up to the same average volume. In my case, -15 dB. I'll confirm with OK, and now all 3 clips should have approximately the same volume. I'll move them together, and then we can listen to all of them.
This is an example for a voice-over recording. One more voice-over recording. And now a very quiet one.
Yes, so we heard that in the beginning, all three clips had wildly different volumes, but through using the normalize function, all of them have a very similar average volume.